So HANA certification, yes. Okay, so why we need to use HANA? How how many ways? How many ways we can use HANA? Okay, then what are the components in HANA? Types of jobs in HANA. So these are the very brief introduction today. So end of this demo class, you guys going to get one good clarity on HANA software or HANA tool. Why should we use HANA and how it is helping the organizations and how faster it is comparing with your traditional database systems. So this is a information we're going to learn today. Fine, the first thing is we need to learn first initially what is in a HANA, right? So let's start. So SAP HANA, the HANA stands for it is a high performance analytic appliance. The first H stands for high performance. So the first word itself, they said it's in a high performance. Based on this, we can understand how fast it is going to work. And we can use this as an analytical appliance or analytical applications. And we're also calling it as an appliance. The reason because we can use because it is going to provide you server and client service to you. So it is a hardware and software combination. The HANA is going to provide you much faster access to your data. Okay, so this is a name stands for. Okay, the first thing is why SAP has invented HANA as a database system. So before HANA discovered, we have a plenty of database systems available in the market since many years. Let's take example of Oracle. Oracle has a RDBMS system for like almost 20 plus years in the market. So most of the companies are using. And we have a Microsoft database system and we have also IBM DB2. These are all the RDBMS systems, right? So these are all like, very like long time the customers are using these particular database systems. So since we have existing systems which providing a good service to the customer, what made exactly to SAP invent another RDBMS system, right? So there should be a certain problem what SAP has faced, then that's the reason they have started looking for a new solution. So to do that one, we need to understand that what exactly the problem was. So when SAP has many modules or applications, these applications, they were depending on third-party database. For example, let's say that SAP has ERP system and SAP has data warehousing system, the BW. So whatever the data they're going to create based on this ERP application, for example, we have a business application, SD, MM, HR, like FICO, PP. So whatever the data you're going to create based on this business applications, then we have to store this data. Since SAP ERP is a front-end applications which can only help of to input the data, but it doesn't have a capability to store the data. So to do that one, SAP was depending on third-party databases called Oracle or MS SQL. So they're using this database as a back-end database. Even for BW system, they were using MS SQL or Oracle for many years. Then when started introducing a new versions day by day, they have started releasing SAP BW 3.x, 7.x, 7.1, 2, 3, 4, 5. So keep the releasing a new versions. These backend databases are not capable enough to manage the enough data to process the data on time. They have a certain challenges. This exactly made SAP to start thinking about. So to release their own database system. Why can't they can customize this database system? Why should they have to design and develop their own database? Since these applications are third-party applications which SAP doesn't have any access to change these applications. That's the reason they have started depending on their own application. They started designing on it. So when they decided to design their own application, then they have to sell this application to the customers. But the customers have already existing database, which are plenty of data, huge data they have it. So once you design and release a new product into the market, just labeling the product, it is a SAP RDBMS system, database management system. Do you think that customers are going to purchase? We have to convince them, right? Since they're already using an existing databases. So it's a very tough challenge for them to convert the existing customers to buy their own new product. It is a big process. So we need to show something new and unique features in this particular product. Then only we can start attracting to the customers. Then they started, if I want to add a unique features into my product, the new product, which is called SAP HANA, let's find out first what is the problems in existing RDBMS systems available in the market. If you can fix those problems into your new database system, then your database system will become hero in the market. Then customers never ask you any questions. Since you're providing a plenty of new features which is not available in existing systems, then customer starts looking for purchasing this new product. Then they started identifying what is the problem in existing systems. The first problem here, we have to note it down, the massive growth of the data volume. The day by day, the data is keep increasing in our organizations. So you mean that, down the line, back to 10 years back or 15 years back, don't we have enough data? Of course, we used to have enough data at the time, but we do not have this much technology in down the line for 10 years back to get more data. We used to get a limited data at the time. But right now, why we are getting plenty of the data from the customers? The reason because of the technology. The technology is widely available for each and every simple common person. They started creating more data. If you go back to the 20 years of 25 years back, the banking systems, let's say that we do not have a ATM facility for the banks. I'm just talking about in a country called India. 25 years back, I do not have a ATM facility for the banks. Then the bank customers, if they want to make any transaction, they have to visit the bank in person. If the bank is around 30 to 40 kilometers, they have to travel for one simple transaction. This is what exactly made the customers to like taking a new accounts in the bank, most of them. Because of the problems, they have to spend a lot of time to create a transactions. But once the banks have introduced the ATM facility, which is available widely in your streets and the roads, airports and railway stations everywhere, then the customers started increasing. Is it really making a more data? No. When the customer start using the ATM, the facility, if they want to make any transaction, if they want to withdraw, if they want to deposit the money, if they want to check the balance, these transactions creating more data. So one person creates 10 transactions per day. So if you have thousands of customers, how many transactions you're going to get? Each transaction is called one record according to the database technology, according to the database terminology. So every transaction creates one record in your database. So you are flooded with plenty of records, plenty of data day by day. Can the bank will say that stop doing a transaction, we are getting a lot of data? No, they cannot do that. They have to provide the service to the customers. So the day by day they're getting more and more data. So that's a data, the volume is keep growing up day by day. And the customers require immediate results. They want the reports on time. For example, if I'm going to withdraw, for example, let's say $200 from an ATM machine, then I'm going to get a receipt immediately. What is a available balance in my account right now? The ATM machine is going to provide you a receipt. That receipt is called the current report about your particular account in the bank. This report is getting generated from the database system. The system is going to identify your record. It is going to identify your account information and what transaction you've done and what is the available current balance. This information is generating as a simple report in a form of receipt. Then it's printing back to you in the ATM machine. So to do this one, it is at least should take generally or normally 5 to 10 minutes of time. But our ATM machine is going to give you in a less than a minute of time. So how fast the system is going to access the data and providing a report on time to you. What in case if there is a latency, if there is a delay in a printing of your receipt, the customers get irritated. They're going to start complaining to the bank. So the bank has to provide a good quality service to their customers. They don't want to get this kind of compliance day by day. So they have to provide the reports immediately. This is another big problem. So then we do not have enough skilled workforce or employees to manage this new technology, or if the database is more growing day by day, how do I can tune my data to perform much better? So we do not have enough skilled employees. Then the next problem here is there is a complicated system landscape. I'm going to talk about this in coming slides. What is a system landscape? Let me give you a brief introduction to the system landscape. A system landscape is nothing but the number of software and hardwares you're going to use in your organizations to provide a service to your customers in your project. That is called landscape. For example, let's say that I have a Java programmer. He's going to join in a company as a Java programmer. In first day, whenever he enters into his office, he's going to first allocate a cubicle for him. Then the company has to provide a workstation or laptop to him. The laptop contains a Windows operating system which is connecting to the Windows server. Since he is a Java programmer, the IT department has to install a Java software on his laptop. Then since Java is a front-end tool, we need to connect this software with the back-end database system. If you clearly observe here, he's getting a laptop, that is a hardware equipment. The laptop contains a Windows software, that is a software, and Java software and database software, and the back end we have a Windows server, that's another hardware equipment and software. So now if he wants to provide the service to the customer, he has to use all this software and hardware equipment to provide one Java enabled applications to their customers. So this is called system landscape. Okay, so I'm going to talk about the complicated system landscape in present RDBMS system. Then I'm going to like a comparison this with our HANA system. Okay, I'm going to show you that later. Okay, now high flexibility of the data is the biggest problem. So these are the very standard and common issues we are facing in the present situations before HANA has been introduced. So now what happens if the data keep grows? For example, let's say I have an image here. This image is we have a truck here. The truck has a certain capacity to carry a certain amount of the weight. Once the amount of the weight is keep growing up, the truck capacity will be very difficult for the truck to carry and move forward. But still it can run, but it will not run as expected faster. So the truck performance will become slower day by day. Keep the data you're going to add. The same thing if you apply to your server or database system. The database system has a certain capacity to hold a data, like a certain number of records, a certain number of size of the data. If the data is keep increasing, the data performance will keep goes down day by day. It becomes slower. This is the biggest problem about data exploitation. And if you see that, which customers who are exactly facing the problem with the data grow, like more data day by day. In this particular image, I have mentioned a couple of social media websites. These websites have a biggest problem about the data in day-to-day life situation. So they're getting a plenty of data for every minute or every seconds, if you ask me. They have a big problem to manage this data. Guys, you have to remember one part here. I am stressing the word to manage the data. I'm not talking about to store the data. The problem is not storing the data. The problem is here to processing the data on time. If you take a present technology, a present generation, we have a much cheaper price we're going to get the hard disks for computers comparing with the down the line for 10 years back or 5 years back. So if you spend around, like for example, let's say if I spend for 3 to 400 rupees, $400, then I'm going to get 1 TB of hard disk. I can store plenty of data. So I don't have an issue, I don't have any problem with storing the data. I have a problem with processing the data on time. So these companies or these social media websites, they have a big problem with processing the data on time. So how they're facing a problem to processing the data? We have a real-time survey. There is a data has been collected for 60 seconds from the top social media websites or companies. So how much data they're getting for every 60 seconds? If you see that, for example, let's go to YouTube. YouTube, they're getting a 60 plus new videos for every 60 seconds. That is nothing but 1 minute. And the video's duration is going to be around 25 plus hours. Just imagine if they're getting this much data for 1 minute. What about 1 hour? What about for 24 hours? That's unbelievable, right? So even you cannot imagine how much data YouTube is getting. But if you please clearly observe here, if you're using a YouTube day-to-day life, you might have understand that YouTube nowadays, they have started, I can say down the line for last 3 years or 3 to 4 years, they started allowing the people to upload the videos for which is more than like a 1 hour duration. If you go back to like um, down the line for 6 to 7 years back, YouTube used to have only maximum video duration it was like a 30 minutes, not more than that. But nowadays we are getting a videos like all the Hollywood and movies which has more than 2 hours of durations also. Okay, so if any customer try to play one particular video which has around 2 hours duration, if the video is not continuously playing, if it is getting stuck up, if it is like a buffering, and what happens to the customer? The customer get irritates, right? So what happened? The customer never visits YouTube again. He complains that YouTube is very slow. Oh, so to play one video, it's taking more than like a 4 to 5 hours. It's a 1 hour of duration video is taking 4 to 5 hours, right? So then the YouTube is going to lose the customers. But if you observe here, irrespective of the length of duration, the video duration, whenever you hit on the play button, the video is processing on time without any interruption. So what does it mean? It means that they are processing the data on time. Guys, you have to remember here, the video file is also a data file. The audio files is also a data file. So they are processing the data on time without any interruption to attract their customers. They don't want to lose their customers, so they have to process. It's a big deal for them. So like this, if you go back to Facebook, they have around 695,000 status updates for every 60 seconds. So it is also a plenty of data. So like this, in present generation, all these companies, they're getting a plenty of data. So how do I process this data to my customers on time is a big problem. This is where exactly your HANA is born. So all the present relational database systems, they have a capacity or capability to store the data. That's like unlimited data they can store. If you keep changing or if you keep adding your hard disk, you can store as much data as you want. But the problem here is I want to process the data on time. That capability the existing systems doesn't have. So these issues has been fixed into one particular application or software which is called HANA. The HANA stands for High Performance Analytical Appliance. So can I call it is a database system? Yes, you can call it is relational database management system. Why it is more effective? Of course, we have existing database systems in a traditional database systems in the market. Then why it is a fast selling product in the world? What is the difference in between other RDBMS systems and HANA? If we have this kind of questions, let's give a clarity to you. The major difference here is HANA is an in-memory database. In-memory means is nothing but the data gets stored in main memory, which is called RAM. So once the data is getting stored in the RAM, there is no time wasted in loading the data from your hard disk to RAM, or while processing, like you have to while you're processing, sometimes what happens is you need to keep some data in the RAM and temporary some data in a hard disk. Okay, you have these options to you, but the major feature here is the data gets stored in RAM and the data will be reading from the RAM. So since the data is getting reading from the RAM, there is no time waste process to read the data from hard disk to the RAM. That time we can save. This is where exactly the word called fast is giving up complete meaningful informations to you. Let's say that I have a computer here. Okay, let me clear this. Let's say for example, if you have a computer has a RAM, then it has hard disk, where hard disk contains the data. This is the old traditional existing system. So if anybody will give input to the computer, the input will process to the RAM. The RAM will understand this and it will send this input instructions to the hard disk to read the data. It will read the data. The data reach to here to the RAM. Then the data will be displayed in computer output, that is called monitor. If you can observe here, there is a process is going on. The input instructions or transactions is going to be sending to the RAM first. The RAM is sending to the hard disk first. Then hard disk is providing the result as per the inputs providing by the RAM. Then the RAM will read the data. The data will reach to the RAM. Then the data will be reached to the computer output device. So there is a huge process and it is a time consuming process. This is exactly where we are wasting a time here. This is time is a difference here in between your RAM and hard disk. Then SAP said that why you want to read the data from hard disk? Let's start reading the data from input. Then I have to store the data in my RAM. That is called in memory. When I'm storing the data into the RAM, then I don't require to go ahead and read the data in my hard disk. That process I can save the time. That's the reason it's becoming much faster. So computer is sending instructions to the RAM is sending back the data to the computer. It's much faster. No questions here, right? But you should get in a doubt here. Since RAM is a temporary storage area, it is not permanent storage area. What happens in case if you have a power cut? Well, if you have a power cut, you're going to lose the data. There won't be any data. Then this will be a biggest problem, right? The customers are going to lose the data. Then SAP has taken this as into consideration. They said that don't worry that whatever the data you're going to store, whatever the data you're going to enter, there will be a copy always stored in your hard disk. How this process will happen? If you want how this process will happen, let's talk about how HANA works. Then you can understand how this process will happen. If it is a HANA system, let's say this is a HANA database system, then HANA has two types of storage: delta storage and main storage. All write operations happens in delta, all read operations happens in main storage. Then we have a hard disk here. So for example, let's say that I am inserting two documents. When I insert the two documents, since it is a write operation, the two documents goes to delta. So once it goes to delta, then automatically the two document goes to here. Unless until if you don't commit or save here these two documents, it will not reach to the hard disk. Whenever you click on save or say commit in your SQL language, the two records comes and stores under hard disk. Okay, so again tomorrow if I'm going to write another 3 records, so when I'm writing the 3 records here, then what happens is I lost the power. Then what happens? Then these 3 records will get deleted. We're going to lose this data, but still we have records in my hard disk, so I'm not going to lose this. Then what happens whenever I'm going to get the power back again? There is a server configuration settings called save point. The save point contains audit information, or I can say log information. What is this log? For example, so and so date and so and so time, let's say that 8 or 10 p.m. System has been created 2 records. This information will be getting stored. It's log information. So whenever we get the power back again, then what happened is system will go and read the save point, what was happened last time whenever we lost the power. Then system will read this, then 2 records will goes and read back from your hard disk, and which will reach back to your delta system. So now what happens if you're going to install, or if you're going to add or insert another 3 records, when you click on a save here, it goes to the main, the reading happens from here, the reporting will happens from here. That's the reason we call it as a read. Okay, then whenever you commit save, it comes and stores here 2 plus, like it is a 3 records here. Okay, earlier we used to have a 2 records, now plus 3 records, it will become 5 records. So we are not going to lose the data. The data will be, one copy will be always as a backup available in your particular hard disk. So this is exactly how we are going to save the data. This is how the data, the process will happen in your HANA database. So we do not have any issue that is, though it is an in-memory database, what happens in case if I'm going to lose the power? If you restart your server or database system, what happens to my data? No need to worry, your data is still available. Wonderful. Then since everything is in a memory all the time, which gives a much quicker access to your CPU for data processing. That's a wonderful feature here. Then can I use HANA as only a database system, or can I use it as for any other purpose? Yes. You can use it as a platform, application platform. It has its own application server called Extended Services. So it stores the data and processes the data from main memory. But while you're storing and processing the data from the main memory, still it is under your control which data has to store in the memory, which data has to store in your hard disk. Still you can control it. You have this feature. This can be controlled by your SQL script language. Yes, that is possible. And you can load the data and you can unload the data from your memory also. So if you want to load the data, yes, by using a commands I can load the data. If you want to clear your in-memory or RAM data, yes, I have again command called unload. By using these functions, I can control my data in the memory. Okay, so HANA is an appliance. Yes, of course, not only platform, I can use it as an appliance. It has a software design. The way it has to work much faster with a certain capability with certain hardware. So your HANA software and hardware combined, both of these are helping your software to run much faster as expected by your customers. It is not only the software which is working here. The hardware is helping your software to run as expected or as much faster. So how many ways I can use HANA? We have is it only RDBMS system? Is it only a platform? Is it only an application server? Do you have any other features? Can I use this as in a different way? Yes, of course. I can use HANA as data warehousing system. I can use HANA as only a database system. I can also use it as an accelerator. I can use it as a cloud purpose. It's a virtual system. And I have one more option called mixed approach. Both, I can use it as a database plus data warehousing system, and I can also use it as application development system. Under this I can create two types of applications: native HANA application, non-native HANA application. What does it mean? Let's go back here. So I said that I'm going to create a native HANA applications and non-native HANA application. If you want to find out this, let me clear the screen. Let's say, for example, this is my HANA application development system. Okay, so here I have a front-end system. Then I have a services. Then I have a back-end system, the database. The front-end system, if you want to design, I'm going to use UI5. If you want to use UI5, the programming languages, we're going to use HTML, XML, JavaScript, blah blah blah. So the services to understand this programming language to provide to your database, we have a service called OData service or XML services. This is like a interpreter in between your front and back end. Then the back end, we have a HANA database system. Since I am creating everything inside my HANA environment, so I call it is a HANA native application development system. Native application development. What is a non-native application? For example, I'm a ABAP programmer, I'm a ABAPer. Can I use HANA for my ABAP programming as a service? Yes, of course. I'm a Java developer. Can I use HANA to create some Java-based applications? Yes, of course. So since it is not inside your HANA system, we do not have a Java or ABAP inbuilt in my HANA system. So we call, if you create these applications, we call it is a non-native HANA applications. So I can use HANA as a application development system as well. So I can create two types of applications: native HANA applications, non-native HANA applications. Let's talk about each one. I can use HANA as a data mart, which is nothing but a data warehousing system. What do you mean by the data warehousing system? I have a various data sources. For example, I have a SAP Business Suite, which is called SAP ERP systems, which contains a plenty of data. Can I extract this data into store in my HANA centralized location? Yes, I can extract the data by using a tools called Business Objects Data Services. And I have another new feature in a HANA called SLT, System Landscape Transformations. If you want real-time data, I can use this particular tool. So if anybody creates a record which is immediately available in your HANA and immediately available in the reporting also, that can be done by using SLT system. I have a DXE also. I can use this DXE by extracting the data from my SAP BW systems. And I have a smart data access also, which provide you virtual infrastructure for entire your non-SAP database systems. So I can extract the data from various SAP data sources into HANA I can use HANA as a data warehousing system. I can store the data here. I can do the designing and modeling, the multidimensionals. I can do a lot here. And is it only for SAP data sources? No, still you have a feature called you can use non-SAP data sources as well. So what are the tools I'm going to use? It's the same similar tools for non-SAP systems. Since a business objects data services, BODS is an open ETL tool which you connect to any data source. Either it might be SAP or non-SAP. So I can extract the data, then I can use as a centralized locations. I can use it as a data warehousing system. Then I can send this data for reporting purpose in SAP business objects or any other third-party reporting systems like Tableau, Quickly. So we have in-memory reporting tools is introduced in the market, which is working much better right now. So those reporting systems I can use to connect my HANA to create a reports. So this is a data warehousing systems. So HANA is providing a service as a data warehousing. And I can use HANA as only a database system. So earlier, we used to have third-party systems for OLTP and OLAP system, but right now I can use my HANA. I can replace with Oracle and MS SQL, like SAP BW is a OLAP system, SAP ECC is a OLTP system. So both systems I can have one single database, or each system you can use individual database system as well. So it is going to provide a service as a database. Wonderful. I can use HANA as a data accelerator. What does it mean? For example, I have a traditional existing ECC system, SAP ERP system, which I'm using a third-party database system, like say Oracle or MS SQL. So I'm going to store this data into my non-HANA database. Since it is not providing a much faster access to me for the data for reporting purpose, so what I'm going to do is I'm going to send this data through SLT to HANA database. This is a secondary database system. Then if I want to create a report, I can access the data from my secondary database systems only for reporting purpose. So it will accelerate your data performance. Okay, so these many ways I can use my HANA system. Wonderful. Now what is a major comparison in between your third-party database system or traditional database system or your HANA database system? Let's talk about, this is my traditional database system which is available in the market right now, which is the old way. If you observe here, I said that in the beginning of the class I'm going to explain to you complex landscape. What is exactly? Let's say that I have a organization. The organization contains a lot of data in the enterprise database. They want to generate certain reports to provide to your management. So whenever they want to generate the reports from your database, so we never give direct access to your enterprise business applications data. We always provide a copy to your ODS system, operational data store. So we allow the IT people to connect from here, not from here, because this should be always in safer side. So we copy the data and move into operational data store. So this is the access point for the people. Okay, then we extract, transform and load the data from ODS to your data warehousing system. Let's say for example SAP BW. On the top of the data I'm going to create indexes. The indexes is going to provide you a performance tuning options to you to improve your query search capabilities. Then on top of this I'm going to create aggregates on my data, which is nothing but summarization of your data. Then I'm going to send this data to my reporting tools to provide a reporting capability to my management. Let's talk about the infrastructure now. This is my like a landscape. So how many softwares I'm using here? First, data in enterprise data warehousing system, like a database system. This is a software 1, and operational data store, the software 2, data warehousing system, the software 3, and reporting system, the software 4. I am using 4 different softwares to provide a service, create a reports, and I have to manage 4 different licenses from 4 different vendors. It is a biggest problem. It's very expensive infrastructure. Okay. Today I have 100 records. I provided a reports 100 records to my management. Tomorrow I'm going to get another 10 records. To process this new 10 records from the system to till reach to the management, it takes some time, the processing time. So there is a latency between the data creation and analytical usage, right? So there is a data latency, obviously, and it is very expensive infrastructure. So what happens in this particular landscape? One system get crash. Let's say, for example, my data warehousing system get crash. Then what happens? Entire your landscape get collapse. You cannot provide the reports to your management. The service cannot be happen here because it has to pass through your landscape. Unless until if you don't fix this problem, then I cannot run the reports. That is the biggest problem. What happens in case if I have all these features into one particular system and the data is in a memory which providing a much faster to me, then comparing to this and here, since it is only one system, I have to manage only one single license, then only one person can manage this particular system. Here, if you come here, I have since 4 softwares we are managing here. We need to have 4 employees, different skills employees also here, right? That is again a biggest problem here. But here, one single system, the HANA, and all the features are available here. I can use it as a data warehousing system. I can use it as a database system. I can create indexes. I can create aggregates. I can see the reports also here. Of course, but not like a full-fledged advanced level of report, but the reports can be still viewable here. And it is not a complicated landscape. It is only one system. And since the data is here and it is in a memory, it runs up to 1000 times faster comparing with your traditional old system. This is one of the biggest advantage running HANA in your enterprise. This is a major difference in between your old systems and your HANA system, right? This is the reason why the customers are looking for HANA now. That's it? Is it only this way I can use or any more information? Yes. In-memory database, since it is a not much like expensive hardware equipment, you can add more data into less space, and it has taken a comparison with the traditional database systems. It is like a real-time the report, this one, it is a 3600 times faster in reporting speed comparing with your traditional database system, and 460 billion records has been analyzed in less than a second of time. Based on this faster performance, the organizations got around 20% of average increase in their revenue. It is a huge difference in the organizations. This is why the organizations loves the HANA system. And it is a combination of hardware and software systems, right? So who's providing a hardware equipments to the HANA? SAP. Then SAP has been tied with a certain major hardware vendors like HP, IBM, Cisco, Fujitsu, and Dell. These guys are providing a service to the SAP to design the HANA based server systems. And how this software technology has been designed. It has a row and column store. I can store the data in a row wise. I can store the data in a column wise. This feature is available here. But if you go back to the traditional database systems, of course they have this feature, but they haven't much used enough till now. They are not aware of what is a column store. We're going to talk about this in coming sessions. This is one of the biggest feature here. HANA by default, it stores the data in a table in a column store. It provides much faster access to your data comparing with row store. The reason because row store is optimized to write the data. Column stores are optimized to read the data. So if you want to read the data should be in a column store. If you want to write the data, for example, I want to just create and store the data. I don't want to use it as for reporting purpose. Then you can go for row store. I want to use the data for reporting purpose. Then the table should be in column store. The compression of the data is much more comparing with the traditional database systems. and the partitions are not required. It will be done automatically here in a HANA systems. Aggregations is not required. The aggregations also done automatically. Then and inserts only on Delta systems also. So we have all this software capability to run your system. Like it's not only the word faster. The software have more features, not only fast. If the system is running in a much faster way, how it is running that faster? Because of these many features is helping your system to reach in according to whatever the speed you are expecting. When you talk about the data storage, row-based, column-based storage. Let's say that row-based, I can give you one general example here, you can understand which is much faster. For example, let's say that I have a bunch of newspapers here. Let's say I have a 2016 from Jan to December, I have these newspapers here, 12 months newspaper. There's a bundle here. If I ask you, can you please pick up the month of August 2nd newspaper, then how difficult is it? Like you have to check because you are not sure where exactly the August 2nd newspaper is located. You have to start searching for this all newspapers. Then you can find it, you can show it to me. But if we have organized the data in like for example I have shelves here and I'm going to label each shelf like a Jan, Feb, March, April and August. Then if I ask you to show me a particular month of newspaper, then you're going to open that particular shelf. It is much easier. You can see this is the reason because it is a column store and this is a row store. Row store we have to start searching the data. The column store, it is going to organize the data in in-memory location according to your computer memory. The data will be located into the memory locations. Then it will be very easy for you to read the particular data. No need to read all unnecessary information which is not required. That is happening in row store. That is a major difference in between row store and column store data. Okay, while the traditional database stored the relational table one row after another, but in-memory computer engine stored the tables in column. Storing the data in columns is not a new technology which we have to understand. I told you that it is still existing in traditional database systems, but it has been not leveraged of its full potential because people still not aware of before HANA has been introduced. But this feature was existing in a old traditional database systems. The column storage is read optimized. So read operations can be processed very fast. That is a one advantage. And you know that we have a OLTP systems, OLAP systems, online transaction processing system, online analytical processing system. Online transaction processing system where your day-to-day transactions happens here. The best example is going to be your ATM machine, which is also we can convert into SAP module, which is nothing but your ECC system or ERP system. Online analytical processing system is nothing but where you can store historical data, which is nothing but your SAP BW, data warehousing system, we call OLAP system, right? Okay, so the file structure will be OLTP system contains a file structure of two-dimensional modeling, but OLAP, I'm sorry, this is a OLAP system. OLAP system has, let me change here itself. So OLAP system has a multi-dimensional modeling. So whenever the data is stored into OLAP system, I can create a multi-dimensional data modeling. This is called multi-dimensional data modeling, which has been explained to you in your SAP BW codes. So this is still possible in HANA because I'm going to use HANA as a OLAP system, data warehousing system. So I can design multi-dimensional modeling in HANA, which is very easy right now. And I can use HANA to analyze the data as soon as it is available. So what does it mean? If your end user creates a record, the record will be immediately available for reporting. That can be possible. This is called real-time analytical feature in HANA. In older days, if you want to get this feature, all your professionals, data warehousing professional has to wait at least hours before they can analyze the data and generate it around your whatever the of data available in your company, but right now it is happening in span of time. Okay, for example, what do you mean by the real-time data? Real-time data, I'm just giving an example here. Let's say I have a supermarket, a chain, to start giving a discount coupons to your customers whenever they visit based on their shopping habits. Let's say that we decide to give a certain coupons to them. Okay, so they could so each customer, whenever they visit your supermarket store, if they purchase a minimum, for example, let's say $100 of products, you want to give them 5% discount. Let's go back to the down the line for 10 years back or 20 years back, when we do not have this database systems or more technology. So at the time, still you decide to give 5% of discount if any customer purchase $100 of products. Then end of the day or end of the month, you have to start analyzing how many customers has been purchased $100 of products. Then you have to list those customers and you have to send information, the discount coupons to them through the mail. Then the customers can start using in a next purchase. What in case if they don't come for the next time for the purchase? It's completely waste of them for the coupons, right? They're going to feel very bad. So this is what happening. This is called without real-time analysis. But when you have a with real-time analysis, if you have enough systems, enough infrastructure, enough computers and very good softwares which can analyze the real-time analysis. See, whenever, for example, let's take your e-commerce websites. If the e-commerce website decided to give you a 5% discount to you, for example, if your product cost reached to the $100, whenever you reach the checkout page, immediately the system is going to analyze your cost of the product, whether you are eligible for this discount. These things will be done by the system. System is going to analyzing all this data. Then the system will pop up a screen in front of you, says that, hey, you are eligible for 5% of discount and this is a coupon. Then what you're going to do? Immediately going to copy this coupon code and you're going to apply in your checkout page. Then you're going to get the 5% discount instantly. You're not going to waste any time. Just imagine the customer, how you feel. He's going to be very happy, right? So this is called real-time. This is the power of real-time analysis. This is the reason why all the companies nowadays, they say, I want the data immediately. I want the result immediately, because they need to start attracting the customers. This is how exactly the real-time analysis is going to help your business. This can be done with your HANA system. Fine. So somebody asked me a question, hey, can I, since you keep talking about it's a in-memory database, I have a, let's say for example, my traditional database system, can I increase the memory to 2 TB? Then can I get similar performance just like your HANA? This was the question actually. The answer is going to be, well, the answer is no. Since you're increasing your memory capacity, you get a performance improvement due to more memory which is your upgraded, but it is not going to work as a HANA just because of bigger RAM. Why? The question. The reason because HANA is not a bigger RAM. It is not only in memory. It is a combination of your hardware and software which is making it is a much powerful tool. And the major feature, if anybody asks you what is a HANA, what is a major feature in HANA, never ever say it is an in-memory database is a major feature. In-memory database is one of the feature. And the major and the biggest feature in HANA is in-memory computing engine. This is what exactly makes a difference comparing with your traditional database system. Having a bigger RAM is just like, one of the feature, but it is not going to make any difference in your traditional database system or HANA as well. And it is why it is really fast. The reason because the architecture, it has an in-memory computing engine and column storage, the data compression, data partitioning, data stripping, and it has a parallel processing of the data, and we have engines which is providing a service to process your data, calculation engine, SQL engine, and OLAP engines. So these architecture, the way they design, is helping to run your HANA is much faster. So this is a few, for example, if you take it, this is your HANA appliance. I have a HANA database system. The components which is available in HANA, HANA Studio, HANA Client, HANA Database. 3 components will be available. So in the HANA database, we have a session management. Session management is nothing but whenever the user logs into your database, it opens a session for the user. Then whenever you start requesting any data, the request will be processing through the execution control, and it will read by your SQL statements or SQL script engines. Then it will send it to your row store or column store tables. Then it will sending the data to the persistence layer and finding out your logger information if it is required. Then the data will be read to your data volume and start reading this. So these many processors are helping to run your software. And compressions, as data have written to the next each other of the same type, there is no need to write the same values again and again. It will automatically get compression. So partitioning and all I'm going to talk about in coming sessions, data stripping and all. But only thing you need to understand, it is running much faster comparing with earlier traditional database systems. And these are all like a 0.04 seconds has taken around 70 retailers they have tested. It's a POC, point of proof of concept here. The SAP tested around 70 retailers. They processed around 460 billion record, 50 terabytes of data in 0.04 seconds of time. That is the power of HANA. And the architecture or the landscape of HANA, I can extract the data from SAP ERP. This is my landscape, HANA landscape, and I can replicate the data from SAP ERP into HANA system, or I can use on or any other third-party RDBMS systems to extract the data, or I can even extract the data from my SAP Business Warehousing system. Then I can send it to this reporting purpose. Either it will be your SAP Business Objects or IBM Cognos or any other third-party business intelligence tools. This is my architecture. It is my landscape of my HANA system. So this is a very brief introduction to HANA. And coming back to here, going back to your questions here. So we discussed about introductions to HANA, why we need to use, how many ways we need to use, what are the components we have discussed. Now let's talk about how many types of jobs. There are 3 types of jobs available in HANA. One is HANA Modeler. The second one is HANA Developer. They can create HANA native applications, non-native application. The third type of job is HANA Administrator. So our course is going to focus on this, HANA Modeling Consultant. So we're going to learn here in this course. I'm giving a major topics. I'm not going to talk about each and every single topic. I'm giving a headlines of major topics. Modeling. It contains a plenty of subtopics. And data provisioning. Data provisioning I'm going to talk about majorly here. SLT. Then I have a MDX. Then I have a DXC. Then I have a MDX, DXC, and Smart Data Access. So all these tools we're going to use, and the major tool here, SAP BODS. We're going to use all these tools. I'm going to show you how to use all these tools to extract the data from SAP and non-SAP data sources. Okay. Finally, the third option is data reporting. We're going to use a tool called SAP BO, Business Objects, and I'm going to show you how to use HANA data to create reports in Crystal reports. How do I create universe? I'm going to show you IDT, how to create a Webby reports, how to create a dashboards, how to create a design studio reports. But I'm not going to completely covering a BO. BO is not our major topic here. I'm going to only show you how to use HANA data to create reports, because SAP BO is again a huge subject here. I'm going to show you a simple reports how to create on this. Okay, so if you want to learn more on SAP BO, you have to start joining a BO class again. Okay, so this is a major topics here. It is going to take around 30 days of duration. Each day it will be 1 hour duration. So sometimes it will go more than that. So we can complete within a 30 days of time. The class timings will be either will be in the evening or morning. I'm going to decide based on the number of students they're comfortable, and it will be from Monday to Friday. So these are all about the today's class. Now the question and answer sessions. You guys can unmute your mic and you can ask me any questions if you have.